Hello and welcome to Tribe Topper. In this video session, you are going to learn about intensity of waves and superposition principle. So what do we mean by the intensity of waves? That, as the name suggests, means how intense a wave is, how energetic a wave is, right? So in terms of physics, we would define the intensity of a wave as the rate of transfer of energy per unit area over which that energy is spread. So in a way you can say it's the power over unit area, because rate of transfer of energy is power. That's power is the rate of transfer of energy, which means per second. You are getting the energy flow per second, and when you divide this by area, so it becomes power over area. That is going to give you the intensity. Therefore the intensity is given as the power acting over a unit area. Now here, because you can see we have considered the whole of this part as a sphere, so let's say a source of light is sending out some waves, then how intense are those waves? So we'll consider some part of this sphere area, which is 4 pi r square, because the area of a sphere is 4 pi r square. So we'll divide by that entire area, we get the power that is emitted or received per unit area. So this portion, how much energy is it receiving? That is the intensity of the wave. So in other words, because you can also define intensity simply the rate of flow of energy flow per unit area. So intensity is power over area, which means you can write it as P over 4 pi r square. The area of the surface area of a sphere is 4 pi r square. So from here, what do you think the unit of intensity should be? That is watt per meter square. So let's have a look at this thing, like how you can relate the intensity with the loudness and brightness. Because if we talk of a sound wave, then we will say an intense sound means more loud, so loudness of a sound. And if we are talking of a light wave, then we'll talk a bright light, so brightness of a light. They both depend on what? That how much amount of energy is received by an observer. So we would say the loudness of a sound wave or the brightness of a light depends on the amount of energy that is received by an observer. Therefore, energy is found to be proportional to the intensity of the wave, in which in turn is further equal to the proportional to the square of amplitude. Now we are saying the intensity of the wave is proportional to the energy, and energy is proportional to the square of amplitude. Now you see this diagram, since we say that intensity is power over 4 pi r squared, that means the intensity is inversely proportional to the square of distance between the source and the receiver. So I is inversely proportional to r square. That means if you are at a distance r, the intensity received is I. Then if you move to a distance 2r, so intensity would drop to how much? 1 by 2r square. It will be proportional to 1 by 2r square. So that means intensity will drop to 1/4. Now you increase the distance of the receiver from the source to 3r. The intensity would drop to I by 9. And you have questions directly based on this type also. So let's have a look at one of the questions. So here we have a question which says that at a distance of 15 meters from the source, the intensity of a loud sound is 2 times 10 to the power negative 4 watt per meter square. Show that the intensity at 120 meters from the source is approximately 3 times 10 to the power negative 6 watt per meter square. So that is going to be a simple one, because intensity is equal to P over 4 pi r square. We have just learned that. And the formula, in this formula, P upon 4 pi, these are just constants. So that means we can say that I is just proportional to r square, inversely proportional to r square. Therefore, the product IR square is going to be equal to some constant, and that constant is P over 4 pi. So we are saying that constant remains the same. Obviously, it's a constant. So IR square, the product is constant. This leads us to another equation, that I1 R1 square is equal to I2 R2 square. Now that immediately gives you what to do. You just have to figure out what is the initial intensity, that is 2 times 10 to the power negative 4 times r1 square. It is given to us. This is the distance, initial distance 15 square is equal to I2. We have to find out the intensity at the new distance into r2 square. We are given the new distance is 120 square. So after plugging in these values and solving, you are going to simply get I2 is equal to, solving, you'll get 3 times 10 to the power minus 6 watt per meter square. So that's the intensity at a distance of 120 meters from the source. And we simply use this equation which was given to us, ISPO 4 pi r square. But the concept we use here is that the product of IR square is a constant. Okay, now let's talk about the principle of superposition. Superposition means what? We can just simply understand from the statement that when two or more waves they overlap in space, then the resultant wave has an amplitude equal to the algebraic sum of the individual amplitudes. So if I have to show here, so let's say there is one wave which is going like this. Then I have another wave which is also going in the same direction, maybe with a slightly less amplitude, like this. But the frequency and wavelength is same. Now when they superimpose, that means when these waves overlap, what do you expect to happen? When these waves overlap, because they are proceeding at the same time towards the same direction, the resultant wave is going to be a bigger wave. The resultant wave has a higher amplitude, which will be actually equal to the sum of the two amplitudes, A1 amplitude of the smaller wave and A2 amplitude of the bigger wave. So you are going to get a resultant wave like this, which has a much higher amplitude than the two individual waves. Right? So we would say we have a resultant wave whose amplitude A is equal to A1 plus A2, because the two waves are proceeding at the same time in the same directions. But what if the two waves, they are going like this, one wave is in this direction and I take another wave of the same amplitude but going in the opposite direction like this. So the two waves being having the same amplitude but they are moving absolutely opposite. When this is at the crest, the other is at the trough, so they are moving absolutely opposite to each other. So the resultant wave is going to be a wave with a zero resultant, right? So that means they negate each other. So I have this white line representing the resultant wave. So when these waves overlap, the resultant wave has a zero amplitude. And why is that? Because my resultant wave has an amplitude of A1 for one wave and negative A2 for the other wave. So it's A1 minus A2. And since my A1 and A2 I have considered here to be equal, my resultant wave has a zero amplitude. So this is what principle of superposition is about, how the waves can overlap. They can give you a bigger wave, they can give you a smaller wave, or they can give you a wave with zero amplitude. So that's all in this video session. You are going to learn about polarization in our next video lesson. Thank you.